Hi class, in the content for this week, we're basically going to look at the graphs that you should have seen at some point in your algebra classes. And this is the basic idea. So all of these graphs are going to be attached to our course depending on, well, what topic we're going to talk about. And mostly all of them are related to the algebra. So the only thing I have to mention is that don't forget that, well, all of your graphs actually need the arrows on the axis as well as on the actual graph or the function, depending on how they're labeling it. So make sure that any graph that you're submitting actually contains these arrows, since they technically go on to the infinity. So what you see on the screen here is basically all the previous graph that you should have seen at some point, and we're going to start this section by graphing some of these by providing at least 3 coordinate points. So if the actual graph requires at least 3 coordinate points, this is what I need you to do. And we typically just do a grid of input outputs. Remember that technically your F represents Y. So we typically select a negative value, 0, and then a positive value if available. And you need at least 3. So this is going to be your Y. This is going to be our Y is equal to X. And then we'll end up with a coordinate grid system. This will be X and Y. So let me start with a negative value. So let's start with technically X is equal to -1. Your Y value is going to be -1. So your first coordinate point is going to be -1, -1. So that is technically there. Let me just make that one a little bit thicker. Actually, I'll put the points afterwards. Then let me select 0. So Y is equal to technically 0 or 0, 0, and then a positive value. Y is equal to 1, so 1, 1. Now for this one, we just need at least 3 coordinate points. So the first one should be -1, 1, which is there, followed by 0, and then technically 1. Your actual line, in this case, it's a function that happens to be going in this direction. Don't forget, let me fix that. Don't forget the actual arrows. And all I need is a basic sketch. Let me fix that. Okay, so let's take a look at the second graph, or in this case B, and we're going to take the same approach, a grid system of coordinate points. So this will be your x's. This is y is equal to x squared, and then technically x's and y's. So we can pick -1, 0, and 1 as well. Careful on this one because of the actual outputs. So y is equal to -1 squared is equal to 1. So technically -1, 1. Y is equal to 0 squared is equal to technically 0. So 0, 0, and y is equal to 1 squared, which is 1, or 1, 1. Now, if you remember what the graph actually looks like, you don't need to plug in additional points, but if it's needed, you can go beyond that. But that's just to confirm your actual graph. In this case, we're going to start at 0. You have 1, 1, and then technically -1, 1. And then as I graph this one, we're just looking at a parabola that's going in that direction. So all I need is basic sketches of these. We'll use technology so that you see how these actually look like. Let's go to C. And you have x's. Y is equal to x to the third. Then x's and y's as well. Let me start with technically -1. So y is equal to -1 to the third. This is -1, or -1, -1. Let's start with 0. Y is equal to 0 to the third. That's 0. So 0, 0, and then 1. This is 1 to the third, or 1, or 1, 1. And let me put the actual dots on this one. So at 0, at 1, and at -1. Now, if you're not clear, or if you don't remember what they look like, you can definitely select more. In this case, let me just do one more, and let's do 2. The only problem is that very quickly these graphs get out of hand and they go on into the infinity. So y is equal to 2 to the third. This is equal to 8, or 2, 8. So this one is actually not even on our grid. So at 2, you're actually out here. And then all we really need is for us to finish the sketch. So this one's going to be this actual graph. Let me go to D, and D is your absolute value function. So this is x's. So give me just a second. So x is y is equal to the absolute value of x, and then x's and y's. Now the main idea on us doing coordinate point system is just to make sure that we remember what they look like. You only need a couple of coordinate points, but all of these graphs, well, you should have seen them at some point in your algebra classes. If not, this is a good section to review them because they will show up in some applications. So let me start with -1, 0, and then 1. So absolute value of -1 is equal to 1. So -1, 1. Absolute value of 0 is equal to 0. So 0, 0, and y is equal to the absolute value of 1. Oops, it's supposed to be 8 equals. This is 1. So 1, 1. And let me plot the points. So we're looking at the origin 0, then technically -1, 1, which is here, and then 1, 1. If you remember what this one looks like, this one it's a V. Let's take a look at graph E. And as we continue, they start getting a little bit more complex. But don't worry, in this case, you're looking at x's, and then y is equal to 3 to the x. So x's and y's. As you select -1, y is equal to 3 to the -1. And that's just a third. You can use a calculator. So this is 1/3. So -1, 1/3. If you select 0, y is equal to 3 to the 0. This is 1. It's one of the rules that we saw at some point in the algebra classes. So this is 0, 1. And then at 1, you're going to have y is equal to 3 to the first, which is equal to the values of 3. So you're looking at 0, 3. And for our actual coordinate points, you're going to have -1. A third is about there. Actually, let me make this larger. I'm just going to say that's a third. Somewhere about there. I think it's a little bit higher. So let me just put the dot right above it. At 0, you're looking at 1, and at 1, you're looking at 3. And then you can actually see the graph actually already showing up. This is your graph. Let me make it thinner. So our graph is going in this direction. All of these are actually curves. And that would actually be the 3 to the x. Now let's go to the last one. And on the last one, to punch in values, you're going to need a calculator. So any calculator will be fine. So you're going to use x's, and then technically y is equal to the log of x along with x's and y's. And then we'll plug in -1, 0, 1, and we're going to go to 2. Now, the reason that we need technically more than 3 here is due to the following. If you remember logs, they don't work with negatives. So if you just use a calculator, and in this case, if you do log of -1, that's going to give you an error. And we'll talk about that in the next assignment when we're using technology to graph these. I'll explain why you couldn't actually get that one. So in this case, you would just say that on this one, it's an empty set, meaning that value is not there. Do evaluate y is equal to the log of 0. And the log of 0 is actually going to give us the same. So if you do log of 0, it's actually going to give you another error domain. So in this case, you would just say empty set, empty set. Next value, y is equal to the log of 1. And that should just be 0. So you're evaluating the actual log of 1. And this is 0. The next one, y is equal to, so your coordinate point is 1, 0. Log of 2, and evaluating the log of 2, let me just retrieve that answer. About 0.30. So I'm just going to say that this is approximately 0.30. So technically 2, 0.30. So you only need 3 coordinate points, but this one came out to be a little bit different. You're basically looking at not having anything on the negatives. And the first one, it's going to be at 1, 0, followed by at 2.30. We need an additional one. Let's select 3. So y is equal to, log of 3. And in this case, about 0.48 if you round to 2. So this is about 0.48. So technically 3, 0.48. So just slightly higher. And then we are going to graph these in the next assignment, but using technology so that you get to see what these actually look like, meaning perfect sketches. And in this case, whoops, let me actually switch that and make it very thin. So our graph is actually going in that direction. So that's your dot, your 3 dots that are actually on the graph. That's actually it for this assignment. Make sure that you copy the sketches, follow along, and submit the same problems that I'm working out in here.